And good morning, good afternoon, good evening, everybody. Welcome on into the Dragon's Den. My name is Digital Dragon, otherwise known as Luke. I am a 3D printer, maker, prototyper, soon-to-be cosplayer here on Twitch. So we do everything from assemble printers to building printers to cosplay helmets and other types of things. Good morning, Creatix Brit. How are you doing, my dear? Welcome on in, and hey, cheers. It's early in the morning. We got to have the coffee. Got to have the coffee to keep us going, get us moving in the morning. Yep, and you were first too. Welcome on in, right? Hope everybody's doing well this morning. I've just been trying to multitask a little bit this morning, trying to get some things ready and set up. I did have some bobbles over since the last stream, and we'll go over that here in a couple of minutes. But we did make a couple of changes in the plans for the electronics, and really it's not the controller but the host computer, which is we were going to use a Radza Zero board, and I was having all kinds of problems. I had basically reflashed the board even though it was already flashed. Couldn't figure out what's happening. If I run it from an external power supply, it boots up perfectly. As soon as I try and run it over the GPIO pins, it hangs on boot, and for some reason I don't know why, but it won't even recognize that it's got the eMCC memory on it. So, not sure what's going on there. I did recently find a couple of Raspberry Pi Zeros. So that's just going to make life easier. We'll just switch over to a known SBC that we know works with these computers or with these printers. And that makes it a little bit nicer because on Gold Dragon, which was the first Rook that I built, it's running an SKR Pico and a Raspberry Pi Zero. So it actually makes it a little bit easier as far as the software will go. There will be a couple other things we'll go over on some boards and mounting that we're going to have to do. But we're still waiting on those boards. They're supposed to come in today. Like whenever the mailman shows up, basically. So with that, let's kind of switch over here a little bit. If you can see, let me move this a little bit closer. Our Raspberry Pi is missing, and we took that off for one good reason, and that's I've never flashed this board yet, and we're going to have to do the firmware update on this board for Klipper before we get too much further. And to do that, I'm going to bring you guys down here. Get you guys a little bit closer here, hopefully. There we go. So in order to do that, there's going to be a couple of things that we needed to do. One is we need to add a jumper right here. And what this is going to allow us to do is pull 5-volt power through the USB-C. Okay. The other reason why I needed to remove that board is we needed to add a jumper right here, which allows us to do the boot. This is the bootloader jumper. And when we go to power it up, we have to hold down this reset button, which is kind of hard to get to if you have something mounted over the top of this area right here. So that's kind of going to be our plan for the day, is to work on this stuff. I really wish I could figure out the right focal length for this so that it would focus. I haven't quite figured out. Does it need to be closer? Far? Oh, there we go. Closer, apparently. There we go. Okay, so let's try that a bit again. So we need this jumper right here, this red jumper. It's right above the USB-C port, because that is what tells it that we're going to run it from 5-volt power. Otherwise, we have to plug it in through the 24-volt DC. Right next to this big capacitor, there's another jumper, and this one has to be there for the bootloader to be active, and then we'll need to press this reset switch here to actually go ahead and get our boot going. So that's kind of what we're going to be focusing on this morning. We're going to flash the firmware, then we'll remount our Raspberry Pi Zero, we'll plug that in, we'll turn the whole system on, and then we'll start to go from there. Well, Brett, not only were you first, you might be the only one on so far this morning. Nope, Pez Liz is here. But she may have just jumped in. Morning, Pez Liz. So yeah, that's kind of where we're at. We will be waiting on some boards, but I will show you some other things where I did some kludging together of a couple of parts to make a mount for those boards. So, and I guess without further ado, we're going to go ahead and we'll get started. What I'm going to do is switch over to the browser window so we can kind of get into our instructions that are over here that we're going to follow. Now, for those of you that may not know, hey, good morning, Free Heathen. Oh yeah, not a problem. Like I said, Free Heathen, on that Power Core EDM machine, that seems like I'll say the closest and the easiest one that I've seen to be able to put together in a home setting without, having a quote unquote shop, right? So I think that would be a pretty cool little machine to put together. The case is all 3D printed, things like that. But today we're going to focus on our SKR Pico. And the nice thing about this board, Free Heathen, because I know you like the Big Tree Tech stuff, let me actually switch back to this scene. As you can see, I'll pull this back just a little bit. Hopefully we won't lose focus. The majority of the plugins are all on the outer edge. Okay, there's a couple under here. So this is the end stop for the hot end. This is your RGB. You do have a couple of headers up here. These down here will be accessible when you mount the board. But it's made so that you can mount the board directly on top of it, or you can mount this directly on top of a Raspberry Pi because they have the same mounting hole footprint. Okay? So the fan will be mounted right down here and just be blowing up across the board. So that's where the fan's going to go. But the other nice thing about this is it's called an SKR Pico because it's actually using the Raspberry Pi Pico, the RP2040 for the chip. And that's why this install is going to be a little bit different. But that's the really cool thing is this board was designed specifically for the Voron V0, which makes it perfect match for a Rook or something along that lines, because same number of motors, same basic design, uses the same bed and the whole 9 yards. Hey, good morning, John Strand. Yeah, so this is really nice. And like I said, even if you mount a Raspberry Pi at the top, which is what I'm going to do, you still have access to all the actual inputs. You will have the ability to plug into the Ethernet 0 and the RGB if you want to add, the party lights. We do have probe pins down here as well, so you'll be able to get to those. And we're going to use a few of these. And I'm going to have to do some interesting wiring. And the reason I say that is we're running a, a Orbiter 2 extruder on this machine, which I have installed as well the Orbiter 2 filament runout sensor. And that's an interesting little sensor because it's basically using a steel ball that rolls out when you insert filament and touches a button, right? So your macros are based on a button push. And then there's an unload button at the top. You push that button and it'll run an unload macro. And that macro heats up the hot end to a specific temperature, which is 235, and then unloads the filament, right? Same thing when you go to insert it, you can just insert it cold. It will grab the filament and say, okay, I've got the filament. It will heat up to 235 and then purge the filament. So it works out really well. I've got this setup installed on both of my 0Gs. They're rocking, but they require 5-volt and ground and 2 GPIO pins. So I'll have to basically pen out to 2 different connectors in order to get the GPIO pin for the second one. So there's at least 3 different types of Manta boards. You've got the Manta 4P, you've got a Manta 5P, which gives you 5 motors, and then the 8P. And you've got standard stick drivers, and I believe the 5P you might also be able to get with the new Easy Stick drivers, which slot in vertically and have heat sinks on the driver. So yeah. And I like the Manta because it's, it'll take either a CB1 module or a Raspberry Pi CM4 module. And so it gives you the host controller and all that good stuff in one shot. But if you want to repurpose one of these boards for, I'll say like an electronics project or like some type of robot, this might actually be better because it's based on the Raspberry Pi 2040 chip versus a standard STEM32 chip. So this might actually be a better option in that case, right? But we're going to switch back over here to the browser window and we'll just go over some of the specs. So it's a good looking board. This is actually the standard board. There's also an armored version, which I have yet to see. Like, I've never seen it for sale, much less out there. But instead of just having the heatsink here, it's actually got a full metal cover over this whole board. So it's actually pretty cool. It's kind of like a pimp my motherboard type thing. Once again, it's a Raspberry Pi ARM Cortex M0 Plus MCU, aka the RP2040. It does have the heatsink that's very familiar if you're used to the SKR Mini E3B3. Oh, thanks for Heathen. It's got Murata capacitors. These have been really good. I haven't had a single cap failure on any of my Big Tree Tech boards. This is a fuse holder with a ceramic fuse in it. So if it does pop, you can remove that fuse and replace it. Uses the Type-C interface. And it has the same, like I said, the same mounting pattern as a Raspberry Pi. So you can stack the Pi under or over with some standoffs. Right? Good morning, Timor. How are you doing? Welcome, welcome in. Logic voltage 3.3 volts. You can do UART mode because the drivers are TMC 2209s. Now, one thing that I will say on the motor inputs is we're used to X, Y, Z, Z, and then E, right? Well, on this board, for whatever reason, it's E, X, Y, and then Z1, Z2 down here at the bottom. So that's the weird setup on this board. Honestly, it doesn't matter. You can plug them in whatever order you want to. You can just go in and pick the, you just have to go in and use the right motor pins for your step, direction, enable and stuff. But the pre-configured Klipper config, you know, it's E, X, Y, Z1, Z2. So just be aware of that. You have some LEDs, blah, blah, blah. You have 3 fans. Those fans are up here at the top. So it's fan 1, fan 2, and fan 3. So we will have this set up with fan 1 being the heatsink cooling fan on the hot end. Fan 2 should be the part cooling fan, and then fan 3 will be the case fan that will be down here at the bottom. And they're all 24 volt fans. So just be aware of that. There isn't a jumper to switch the thing here. We do have a nice little wiring diagram here. And the other reason that's important to know which motor is which is because we're doing sensorless homing on X and Y. These are our diag jumpers. So there's one for each motor. So we have jumper connection on X and Y because we will be using the sensorless homing, which means we cannot use the X and Y in-stop pins here. They are now dead to us. We cannot use them for other things, right? We have probes. We've got RGB. We've got dedicated probe. This would be like your PNP or NPN probe. So your inductive probe. You've got spots for your BL Touch if you want to use those, which we will wind up using those. We'll have to do a little bit of modification for that for our in-stop probe, but we'll get that to work. Or not our in-stop probe, but our filament sensor. So what we're going to need to do now is, once again, we've added the jumper down here. This is the 5-volt jumper that tells it that it's going to draw power from the USB-C connector. So we're going to use the USB-C. This is Little Tree Tech for the smaller builds. So this is specifically designed for the Voron B0, which makes it perfect for a Rook, which is basically the same size as a B0. So we need to put a jumper here so that we can pull power through our USB-C. We're going to put a jumper right here above this cap, and this is the boot pins. And then we'll need to push this reset button right here. So that's why I took the Raspberry Pi off the top. Okay, and insert jumper cap on the boot pin. Click the reset button to enter the burn mode. So what I'm going to do is I'm going to plug in my USB-C, and this is going to my laptop. So you're just going to have to follow along with me. This is kind of a booger to get in where it's at. There we go. So we've got that, and it told us to push this reset button. So we'll push that reset button. Now what it should do is that should apparently I moved that down. It should now show up as a drive in my computer. And it'll show up as RPi-RP2, which it does. And this makes it so much easier because this now shows up as a USB drive. All you have to do to drop your firmware is to take a file and just bring it over and drop it. And that's it. You've now got Klipper firmware. Oh, this board will be exposed. There's no other back cover on this. This is the back plate on the printer. So that's there. And it's just got a basic, there's like really nothing on it. It's just got a couple of text files on it. So what we're going to do is there's going to be two different files that we can look at. It'll be either, and I'll just open the Klipper folder here. There will be a Klipper UART UF2 or a Klipper USB UF2 file. So you will download the one that you want and load that onto your RPi-RP2 drive. Because we're going to plug in using the dedicated UART cable, we're going to do the UART version. If we were going to plug in using a USB to the USB-C here, then we would use the USB version of the firmware. Okay. Oh yeah, the drag and drop, it makes it so much easier. Like you can go through and do the full Klipper config like normal with the make menu config. You don't even have to do that. They've got predefined files here. All we're going to do is, darn it. Yeah, I'm just going to click. Oh, that's not going to matter, darn it. Because I need to download it over on this side. Have I? I have not. So bear with me 1 second. SKR Pico. No, Pico, darn it. Ah. Bear with me 1 second here, folks. Go there, go there. and grab that. Okay, so now that I've got that downloaded, once again, all I have to do is take that Klipper file and drag it over to the Raspberry Pi drive. Okay, and it's wanting to be cantankerous right now, so I'm just going to unplug it and then plug it back in. So how many free active pen ports do you have not in use? It depends on what you're plugging in. All right, so why are you being that way? Whatever reason, it's being a butt, and I don't know why. All right, we're going to actually just see if that quote unquote did it. If not, I may have to actually try and do it over on the other computer, which would be interesting to do. So I'll pop that off. The next thing is, actually, you know what? We're gonna do it the other way. Bear with me one moment because I'm gonna steal a plug from my light. We're just gonna plug it into the Windows machine over here. See if we can't get it to play nice now. Uh-oh, ad break. And we're back. So, I mean, Free Heathen, we've got a lot of pens. I'll show you the pen out here in just a minute after I can try and get this done. Did that show up as a drive? It did not. Why did it not show up as a drive? That's there. That's there. Hit the reset. Not showing up as a drive, and I didn't hear it do the. Oh, there we go. Didn't have the cable all the way in. No, don't scan for threats. It's good. There's my RPi drive. So I will need to come over here and grab this file. And then all we're going to do, let me switch this over to the Explorer view. We've done the downloads, so we're just going to go to the downloads. We're going to grab this Klipper file right here, and we're going to drag it over to the RPi, RPi-RP2, which is our F drive. So we're just going to grab that, bring it down here, and the drive goes away and then comes back. So at that point, it should have the new firmware on. Okay, we're not seeing that UFT2, but if we look at I believe if we look at one of these, bootloader 3, Raspberry Pi 2. All right, well, that doesn't really show me anything, but my understanding is that's it. That's all we need to do. So we should be good. Next up, we will power it down. So let's see. The mainboard will automatically reboot and update the firmware. The computer will re-identify the flash drive, which means the firmware update is complete. Unplug the jump cap and click the reset button to enter normal working mode. So that would be the jumper here for this bootloader piece. So we'll take that jumper off, and then we'd hit the reset, and that should reset it into a normal operating mode. Okay. And since we now need to do a little bit of other configuration, we're going to go ahead and unplug it from here. And then I will go ahead and plug this back into my light and get my light back on. Okay, we're back up and running. So we've got everything powered down. We need to go ahead and install our Raspberry Pi. And like I said, we were going to use the Radsa Zero, but I was having too many issues. So I decided to go back to just a Raspberry Pi Zero. And I'm using these standoffs that I had. I can't even tell you where they came from. I just had them in my bin. So we're going to use these standoffs here. And we're just going to mount this in these two holes here on the left. Okay, so that board's now secure. And we're going to plug in our wires, and our wires are color coded. So you'll have two reds, a black, and then two colored wires. So on the outer edge here, we're going to plug that in with the reds at the top. Because on our GPIO pins, it's 5 volt power, ground, and then the two UART pins. Okay. So now that we've got that set up, we can also take off the jumper cap down here for our 5 volt. Like that. And we should be able to just turn it on. So we'll go over here and we'll turn on our power. and we'll see lights up here on a Raspberry Pi. So it's coming up. And on stream, or not on stream, off stream, I did go and install the software on the Raspberry Pi. Very simple. Use the Raspberry Pi Imager software. Oh yeah, definitely, Daddy Wazzy. You use the Raspberry Pi imaging software, and you can use a special, I think it's special purpose image, 3D computing or 3D printing, and you can go in and just install Mainsail OS. And the nice thing with installing Mainsail OS in that way is you get your full Klipper install, Mainsail, and Crow's Nest. So all you need to do is find the IP address of the host, which once again I'm going to do over here because I don't want to expose my network to y'all. Love you guys, but you know, don't want you to see everything that's on my network. And the nice thing is this should come up as Raspberry Pi. Seriously. And yeah, that's what I thought. That was going to be that one. Now it's going to make a liar out of me because it's not coming up, or at least not showing up yet. Submitting. Black Dragon. Cyber Dragon, Fey Dragon, Death Dragon, Iron Dragon. I'm trying to determine why it's not coming up, and it might be not coming up because it's, for whatever reason, it's got the same IP address as something else, but it shouldn't. And this is a Gen 1 Raspberry Pi Zero, so it will only come up on a 2.4 network. It will not do a 5G network. We're going to go ahead and try and power cycle this. Every once in a while, for whatever reason, I have issues with Raspberry Pis that, like, they come up, but they don't get on the network for whatever reason. So we'll take a look at that. I do know that there are a couple of files that we need to modify in order for the Raspberry Pi to talk over UART. There's a couple of things that we'll have to modify, and doesn't show it here. Where does it have that at? The Wi-Fi. So yeah, this is a Wi-Fi enabled one because, like I said, I had it on the network yesterday when I was, or actually not yesterday. It was Thursday night when I was sitting on your stream, Creatix Brit. I actually reflashed this, and I had it up and running. Now I'm just trying to figure out why it's not coming up. It's really, really, really weird. Let me double check something. I may have, in my infinite wisdom, um, so I was wondering if my if I had, I'll say, shot myself in the foot by um, limiting the number of IP addresses my router will give out, but that's not the case. Because I have done that before where I've limited the number of IP addresses that the router can hand out and then sat here and fought and fought and fought trying to figure out why a device wouldn't come up on the network. All right, so no worries. We can fix this. We can fix this. So what I'm going to do is I'm going to plug this into a card reader and take a look at it over here on my Mac real fast. Are you doing any more HueForge prints today, Liz? Okay. Well, I don't know why. It should just be as easy as, you know, when you do the Raspberry Pi imager, you can go in and say, hey, here's my wireless information. Normally comes up, but for whatever reason, if it doesn't, you can basically go and create a WPA supplicant file and kind of nudge it along. So that's what I'm going to do. Oh, yeah. I know there's supposed to be some, like Polymaker's providing the transmissivity information with the, or on the product page now, correct? I know they were talking about that, and I don't know if they have it on the product page or like a full list that you can pull down. And let me see, wpa-supplicant.com, base configuration. Must have specific things in place, so I'm just making sure that those are in place. That should be good. File, save as. So, I think we need to go to mainsail OS. Why would it be easy? Oh, I'm sorry. What I'm doing? Hey, good morning, Chris. Long time no see. So Britt, I think I have just like 2 more things to print out in the ABS, but I need to really start getting in and doing all the sanding and all that good stuff to get everything set up for paint. And then we'll start doing some painting. All right, now I'm getting confused. Oh, here we go. This is, I think, what we're looking for. Build the image file, which we didn't need to do because we dropped and placed it. We will do this part in a minute. This is what I was looking for, was this part down here. If you use the UART communication with the Raspberry Pi, we will need to set that information. We can do that via SSH, once I have an IP address, that is. So we'll put this in place. Turn it on. And we'll give it a few minutes. Because there was one other thing that I was thinking of. I was pretty sure that I had installed this and then logged in, but I may not have, which means it's doing 2 things. It's expanding the file system in the background, and because I gave it a named account for SSH and stuff, it's probably going through and doing some permissions things. Yeah, definitely. So, but Britt, I've got, like I said, I've got all the parts printed. While this is doing a little bit of its little dance here, we'll come back over here. Like I've got all the parts printed. I just need to work on getting them put together, either with epoxy and CA glue, or what I started trying to do on a different set of pieces was an ABS slurry. Since all this is printed out in ABS, you can basically weld them together using acetone. So I need to get all the main pieces put together, and then I can go in and start sanding and doing things like, you know, filling the gap that's going to be there between the 2 pieces, of course. So I'll have to use some glazing putty, fill in the gap, and then go through and do the priming and all that good stuff. But I think this is the rear abdomen area. There's 4 pieces that make up the front abdomen area. So I think this will be the lower piece, and then these will be the upper pieces, right? So I just have to start putting things together and then fill, sand, prime, paint, and all that goodness. So yeah, I'm going to start working on that. That's going to be the other filler space between now and Earth. And hopefully I'll have a couple of small pieces that I can bring to Earth with me, just to kind of show the progress of how I'm going through it. But my plan is, since the majority of the armor is white, sandable fillable primer, glossy white paint, and a gloss clear coat. And then, oh yeah, it was great sitting there last night. When I saw you came on, I was not planning on getting back on Twitch last night, Chris. And I saw you popped on. I was like, nope, yep, go. Let me jump up there and go visit you, because I knew you were going to be working on Black Box. So, and by the way, I am rocking my, Earth 2023 shirt. Okay, so we've given this a little bit of time. Looks like it's still doing some writing though. So I am a bit torn though, Britt, in I printed the helmet out in Cosplay B, right? And this is 3 pieces. So the dome's 1 piece, this front mask is a piece, and then there's the rear. So I printed this out in 3 pieces, but it came out looking really rough. And I think it was just I wasn't running this hot enough with an obsidian nozzle on a Revo. So I've got a lot of, like divots and holes in here. Definitely, they'll be able to be filled and stuff, no worries. But, oh, thanks for the shout out, Maker Deck, and I'm sure I can account Pezliz for that. And I'm also reprinting it in ABS. So I've got the 2 lower parts in ABS. I just needed to print the dome still. And so I'm going to do both of these helmets, one in the cosplay and one in the ABS, and see which one I like the best. But yeah, my hope is to have that done for Halloween, or at least some portion of it done by Halloween, so I can wear some portion of it. And, oh, we got an ad break. Let's let that go through. And meanwhile, let me... Of course you timed out. Why wouldn't you? I'm going to look through and see if it has come up on the network yet. I'm still not seeing it on the network. Which is really rather annoying. Always the case, it should be just so simple, so easy, until it's not. All right, thanks for the alert, Chris. We'll see you in a few. Okay. Well, this is rather annoying. We'll be trying this one more time. Oh, okay, well, there you go. That's my issue. So this is the version 1.3 board, and I just double checked, and this is the original Raspberry Pi Zero, which does not include Wi-Fi. Well, that's a booger. So what do we want to do? Exactly, Pez Liz. So I can do a external Pi for now. I'm just going to have to get one of these on order. That would mean I'd also have to reboot or reflash the Raspberry Pi Zero. So what are my other options here? What else do I have? Let me check my other Raspberry Pi here and see if it's the same issue, which I think it might be. Two cups and a wax string, yep. I mean, I guess if I had to, I could put a Raspberry Pi 3B and just mount it across the top, but... And yes, this is a version 1.3 as well, which means no onboard Wi-Fi. Well, crud. We'll make something work here in the interim, don't worry. Now, if I do it this way, I will have to So I do have a Banana Pi, but the Banana Pi I have to use an external antenna with. So I'm going to definitely have to order a version of the Zero that has Wi-Fi on it, whether it's a 2 or a regular. I actually don't have a Manta and CB1 lurking about. I have a CB1 and an RPi 4 board, or at least I believe I've got a CB1. Give me 1 second. I think these are stepper drivers. Yeah, so I have a CB1 and a Pi 4 adapter. Or I have the Raspberry Pi, or not Raspberry Pi, but the Big Tree Tech Pi V12. Which the CB1 and a Pi 4 adapter would basically be the same thing as doing a Raspberry Pi 3. Which, what I can do is pop that out of its case. Oh, hey, Great Gamer 23. Hello. Do you like pan masala? I That's a kind of a weird name or a weird question to ask. Not sure how to address that. Okay, we'll have to redo some mounting here. Let me find my standoffs. By find, I mean let me go grab my standoffs. Or standoffs. Those are 20 millimeters in length, so 25 millimeter screws would work perfect. Like that. We'll do a little bit of minor surgery here. Bring you guys back up here. What I'm going to try and do is do one side at a time. No, it's probably not going to work. I'm going to take them all off. So the holes on a Raspberry Pi board are like a 2.5 millimeter opening. I'm just going to open mine up to a 3 millimeter opening. Ah, okay, it's a tobacco chewing thing. In that case, no, I don't, but I don't begrudge people and their vices, so. All right, so what that allows us to do is screw. We'll have our standoff. And then we'll go through the it's not a well, I'll be darned. I thought these were threaded all the way through, and they're not. Oh, maybe they are. Nope, they're not. Damn. But that's okay. I've got a plan. Plan B. Plan B. So the downside to this is when we go to do some other wiring down the road, we'll have to be careful because well, not be careful. I'm going to need to get to some of these connections here. And depending on which way I mount the board, if I mount it like this, which will make it easier to get to the connectors, then I'm going to cover these up. If I mount it the other way, it would keep these open, but then this isn't going to make it over to plug in. So we'll have to figure something else out down the road. But my plan is, I'm just going to put this in with 2 bolts, one on each corner. And that should hold us in place for the time being. And once again, I am going to be searching for a Raspberry Pi Zero that will be the best overall solution here. Right, so like I said, we'll have to get a Raspberry Pi Zero here so we still have access to the ports down here at the bottom that we need, but this will let us continue to go forward because I want to work on getting the software configuration set up for this board. And that's a little annoying, but we'll live with it. We'll live with it. Okay, so we got this. I should be able to take this same card that I had in the other one and plug it in here. And if everything goes right, we'll do a power on, and it would just be like we had the other board in. We've got power up here, power down on the board underneath. Is this a bomb? No, this is a 3D printer. So yeah, this is a 3D printer. And I'm just checking again for a wireless device. I'm not seeing it, so no worries. No worries. No mas. There we go. Now I'm seeing the second light. Okay. Now I'm getting annoyed. So this was the original card that was in it, and this was originally functioning as mainsail. So we will throw that card in there and see if it'll at least come up on the dang network. There we go. There we go. Okay, so I now see it, so that's good. Hey, Tactile, how you doing, my friend? I do like hunting. I'm not sure if I am going to hunt this year. I'm having some problems with my eyes. I'm going to have some eye surgery. So depending on when that happens, whether will determine whether or not I'm actively hunting this year or just acting as a mentor because I take part in a hunting mentoring group. So let me bring up Putty. And get logged into Putty or logged into the Raspberry Pi. Okay. So browser window. Putty. So we're now into the machine using Putty, and we need to check a couple of things out. In order for our UART communication to work correctly, we need to check for a couple of files in the boot folder. So we're going to cd to /boot. And then we want to do a sudo nano cmd line.txt. Yes, put in your sudo password, which would normally be Raspberry on a default Pi installation. Mine is not. And what we're looking at doing here is just removing, if it's in here, console equals serial 0, comma 115200. So I've already taken it out, but I will show you what it would normally look like. Maybe, because of course it won't let me do a cut and paste. Then normally this is what that file would look like. And what it tells you to do is take out the console 0, 115200. And what that's doing is it's taking out the serial console port from the configuration so that it's available to be used over UART. Okay? So I primarily do Twitch and then cross-pollinate them over onto YouTube, Great Gamer. And every once in a while I'll do some YouTube only content, but it's normally serial videos for my printers. So we're going to take that, we would take that line out and we would save this file by doing a Control X for exit, Y saying yes we want to keep the buffer, and enter to accept the same name. The other thing that we would want to do is modify the config.txt file. And normally what you would do is come all the way down to the bottom and you're going to add a couple of lines if they're not already there. So we're looking for DT overlay. So we'll just use our down arrow to come down through our file. Okay. So you'll see there's some DT overlays here for infrared. We don't want that. There's your audio on, your display. Enable DRM VC4 driver. That overlay just does for video, which you'll need if you're going to do a camera on here. It's going to keep going down. Okay, so this area right here is what we're looking for. So enable hardware UART for serial communication, which also disables Bluetooth. So you would uncomment both of these if they were commented out, so that it enables UART and the DT overlay disable BT, or disable the Bluetooth. Now there's a different parameter here that they tell you. So I will go ahead and modify this one. Well, what I'll do is knock that one out, and I'll add the other line in here, which is DT overlay equals pi 3 dash mini UART dash BT. And that enables the mini UART and Bluetooth. And actually, if I remember right, we want to take that off as well, because you could have some issues with the Bluetooth. We'll say Control X, Y, and enter to save that file. And then the rest is going to be in our printer.config file. So we're done here. We shouldn't need to do anything else in this interface. So let's go back over to the web browser. And see if we can actually get to the main sale interface. So we're going to 192.168.10.241, which is this main sale configuration on this board. Free Heathen, I have hunted for dove. I have never hunted for duck yet. I primarily hunt deer. I've tried to go turkey hunting twice, but both times I've tried to go turkey hunting, some family medical emergency has popped up, and I've had to not be here for turkey season. Yeah, dove is good. So what this is telling me is that the MCU setting in my printer config is not correct. I'm pretty sure that my entire printer.config is not correct, especially since this is a printer config file for a mini E3 V3. So we'll do a couple of things to start with. Number one is we're going to bring Gold Dragon up onto the table. And we're going to do that because we're going to plug it in and we're going to steal its config file. And by steal, I mean we're just going to copy paste it. But so Gold Dragon here is running the exact same, well, pretty close to the same config. It's got BTT SKR Pico board, and it's got a Raspberry Pi Zero. So what I would be able to do is come over here and log into Gold Dragon, which may take a couple of seconds for it to fully come up. Yeah, I've had moose, elk, and bear in the past. I don't have moose or elk down here in North Carolina, but I do have deer, and I do have black bear. And this is no big deal. I'm just waiting for the Raspberry Pi Zero to start the web interface, which it looks like it's doing. Oh yeah, we do have pig here. I have not gone wild pig hunting, but we do have a lot of wild pig here, especially towards the coast. Yeah. I'm just being impatient. The Raspberry Pi Zero does take a little while to actually bring up the interface. So Raspberry Pi Zero 2W would be better. Come on. Oh, apparently it's raining outside. Just checking real fast to see if my KB3D order came in yet. No email notifications, so nope. So between 12 and 1. So hopefully soon we'll get that email or get the mail in, and I'll be able to run out real fast. I'll be right back, run out and grab the mail, because what we're going to have is the board back here and the board for the back of the. So what I'm going to do is I'm going to install the V0 umbilical, which will have a board that'll mount to the back of the orbiter here that all of my tool head wires will plug into. It'll have a 14-pin cable that'll go from that board to another board that'll be mounted along this back rail. And then on the underside of that will be all of the connections for everything on the tool head to come back down to the SKR. So it'll be a little bit nice. It'll make wiring a little bit easier. And so that stuff is on its way from KB3D. So now we're on Gold Dragon, which is my first Rook. And what I'll be able to do is come over here to the printer config file. And literally, I'm going to do a Control A, Control C. Come over to 241, which is the Rook 2020 build right now. Do a Control A, delete, and Control V to paste. Okay, so I have just taken the config from Gold Dragon and dropped it onto this one. We'll need to change a few things. So this is a Rook 2020. This does not have a Revo. This is a let's say a Rook CHC hot end. This will have a orbiter, direct drive, orbiter be 2.0 with filament sensor. SKR Pico, TMC 2209s on X, Y, Z, and E. Centralist homing for X and Y. ZMAX will have a physical end stop. And it's an all 24 volt system. We are doing UART, so we should be able to keep this dev TTY AMA 0. Shouldn't be a problem there. And for right now, everything should be golden. I'll need to update the extruder information for like the rotation distance and things like that, which is no big deal. I did just lean over and double check. This is a 1.8 degree motor, so that will be 200 steps rather than 400 steps. The rotation distance and gear ratio stuff will be different because this is running a BMG gear, this is running a orbiter. So what I can do is come over here to Death Dragon, which is my 0G that sits right behind me. And that's running an orbiter, as you can see, with a filament sensor. So I can come over here. Good God. Come into its printer config, come down to its extruder. And we'll have rotation distance. We'll just add that line in. Nozzle diameter is a 4 millimeter nozzle. 1.75 is our filament diameter. The heater pen should be the same. That should be good. We'll redo our PID, which is no big deal. This is an all metal hot end. So we're going to make this 300 degrees. Everything is printed in ABS on this printer, so no worries there. Hey, Photocement, welcome in. Minimum extrude temp for PLA would be 170. That and that should be good. We'll grab these couple of things here. So this is our max extrude distance, cross section, pressure advance. So we'll replace that stuff. This PWM cycle time is not necessarily needed for the hot end or the bed. It's really needed if you're running a mains voltage. Run current on our orbiter should be half. I'm just going through and checking a couple of things. Thermal section for our heated bed. That might be slightly different. I'll have to double check that on the LDO bed. Once again, we'll PID tune, no big deal. So our hot end heater fan goes to fan 2 on GPIO 18. So fan 1 is our part cooling. Fan 2 is the hot end fan, and then fan 3 is the controller fan. And we'll work on our max locations here once we actually get this set up. So I'm just going to do a save and restart and see if this comes up. And it came up and it shut down automatically because ADC is out of range. So ADC out of range, what that is I currently don't have a thermistor plugged in for the hot end or the bed, right? The wires are here on the board, but they're not physically connected at the other end yet. So that's an issue. How do we get around that? Well, it's rather simple. We pull these two wires, which should be rather simple. Come on. There's one. So we're going to pull these two wires out. And this is just a bundle of thermistors, right? Just the little glass tip thermistor. So all I'm going to do is I'm going to take two of these and plug them in to my thermistor jacks. We'll go one there. Grab another one and put it up there. Okay, so I now have two thermistors in there, and I'll do a firmware restart. And I come up and I'm running. Okay, that's how easy it is to start getting in and doing and validating some of your config before you can really go in and do, because we're missing a board up here, we're missing the board back here, none of this is connected yet. But what we will be able to do now is start running through some of our checks while we're waiting for our other two boards to come in, and we can get those in, get them installed, and start wiring those up. So we've got a basic config here. What we can do is come over to our Voron docs for our initial setup. So this is just the Voron design documents, and under the build and initial setup, or initial startup, sorry. What this does is it kind of walks you through some initial checks just to make sure that, one, you're able to connect to your controller board with your Klipper install, which we can. And then we're just going to do some basic checks. So first check, are your thermistors reading? Well, we knew they weren't reading before because neither one of these cables were connected to anything. So it failed, right? So now we've got just some basic thermistors plugged in, and we are reading temperatures, and those temperatures are the same, which is good since they're in a bundle and they're physically like right next to each other. So thermistors are working. Verify your heaters. We can't do that. The bed heater is connected. However, I don't have a live thermistor sitting there on the bed. So it's kind of hard for me to turn the bed on and say, hey, is it heating up? Other than physically touching the bed with my hand to say, yes, it's heating up. So we'll hold off on doing that just yet. Stepper motor check. This is a thing that we can do. And we're going to kind of look at the Voron V0. So we're going to say the stepper X, which is, so X, Y, I've got the tape on them now. So I expect this motor to turn clockwise, and then this one will turn clockwise when I do the stepper buzz. Okay. What I'm going to do is come down here and, well, where's the stepper buzz command, darn it? Oh, here it is. We'll grab this stepper buzz command. We'll just copy that. We're going to come over here and we're going to paste that into our console. And then when I hit enter or this little send command, I should see this motor and it should rotate clockwise, then counterclockwise. And it's only going to go a millimeter. So I'm just going to watch this motor. And it is going clockwise, counterclockwise, clockwise, counterclockwise. I'll bring you guys in a little closer so you can see what I'm talking about. Okay, so that was working. We're going to do the same thing. So we're just going to go back to our console and do an up arrow and go to Y. Or I'm sorry, and switch it over to the Y motor. And so this motor should go clockwise and counterclockwise. It might be easier to see the so these two motors are moving in the right direction when I tell them to do a stepper buzz. I can do the same thing for the Z drive. So in the Z drive, because the positive direction should be down, it should go down, then up, down, then up. So all I did was I just lifted the bed a little bit with my hand. See if I can't turn this around. Right, so I'm just going to lift the bed off the end stop is what I'm doing. It's just holding it up just a tad. And I'm going to tell it to run. So it's going negative, then positive, negative, then positive. So it's going up, then down. So this tells me the direction is wrong for Z. And that's what happens on a belted Z without gearing, is it drops as soon as it removes the power to the motor, is it'll drop. But finish your coffee. Yeah, I'm working on it. So we know our Z motor direction was the wrong way. So we'll go under Machine, into our printer config. We're going to scroll down to our Z motor. And where our dir pin is, right before the GPIO 28, we're going to put an exclamation point or a bang symbol. What that does is it reverses the direction. Okay? So we'll save and restart. We'll come back to our dashboard. Once again, I'm just going to lift this up a bit. I'm going to come over here and do an up arrow to get back to my Z stepper buzz. And we're going to send that again. And now it goes down, which is positive. And then it drops, of course. So now what we want to do, we've got our stepper buzz and our motors are working in the correct direction for X, Y, and Z. Okay. We'll work on the extruder later once we can get that wired up. So the next thing we want to do is query our end stops. Once again, our Z is all the way down. So if I query my end stops, I can do a query end stops command. And I should get X open, Y open, and Z triggered because Z is down on the end stop. I'm going to lift this up off the end stop and run that command again. And you'll see all three are open. The other place you can do that is come look at the machine, come down to the bottom, and you'll see an end stop section here. You can do a refresh. They're all open because I'm holding that bed up. If I set the bed down and do that again, the Z end stop is now triggered. So that's telling me everything's working. Oh, biscuits and gravy. Really? You're going to throw that out there, John Strand? You're killing me. Yeah, coffee with biscotti. Nice. The Starburst all pink drink mix. Oh, nice. Okay, so our end stops are working. Once again, even if I take this and move it all the way to the side, front, back, however, it's not going to matter because we're doing sensorless homing for X and Y, so it won't trigger just by moving it over one way or the other. But the next step is, now that we've checked our end stops, is we're going to do an XY homing check. Okay? So what we're going to do is we're going to check one at a time and see if they go in the expected direction. So I'm just going to grab my excess wires here, hold them up out of the way, kind of like, you know, pulling the drunk girl's hair up after the night out on the town. We're just going to hold that out of the way. And I'm going to come back over here and I'm going to tell it to home X. And I'm going to expect X. Let me see which way. Hold that thought. I'm going to come back here to my printer config and just double check something. So X is set to home in the positive direction because that's set to true, which means X is going to home to the right. Y is also going to home to the positive direction, so it's going to home to this back right corner. Okay, so what I'm going to do is move my tool head in the center, just kind of center everything, because that's going to give me a second or two once I say start to home So if it goes in the wrong direction, I'm just going to go emergency stop up here in my interface. Oh yeah. Hey, I've done the reference. Most guys are like me and they keep their hair cut pretty trim. But if you got a guy with some long hair, you know, you might have to do a brother a help and hold the hair out, you know, Friday night, Saturday morning. Yep. So what we're going to do is we're going to tell it to home X, and it should move towards the right side, which it did. So that's good. That's moving in the right direction. Y should go back. And it did. Now it hit and then moved over because what happened is it hit the, because I'm using a different tool head, it actually hit the, the bracket that's holding in the top of the rod. So it hit and then you saw it move to the left as it kind of hit and went around the rounded edge of that rod stop. So that's something to note. But looking at how everything's lining up, won't be that bad. We can deal with that, and I'll show you why. So the next thing I'm going to do is turn all my motors off. I'm going to pull this in the middle. This is going to get interesting because I'm going to have to grab this stuff here in a second. Because I want to hold my Z-axis up off the bed or off the end stop. Because when I hit one of those X or Y, you may have heard it or saw it go dun, dun, dun. It's trying to move the bed down to do a safe home. So I'm going to say home all. It'll move the bed down, move this over, move it back, move it around, and then drop the bed down to the bottom. Okay, so everything homed well. You've only ever been sick once and it was mudslides followed by beer. Yeah. Oh yeah, yeah. Any type of liqueur and then a lot of beer, yeah, that could turn bad. What is it? Normally it's liquor than beer, have no fear, beer than liquor, never sicker. I believe is how it goes. It's a wash. If you drink too much, you're going to throw up, period. Now what I will say from my time in Germany, let me come over here and check my Twitch, see if Mrs. Dragon's up and lurking. She's not. So from my time in Germany, I will tell you this. If you go out drinking, eat something before you go to bed, preferably. Many, many times I have closed out 4 different bars in Germany. And then we stop. And it's funny because the taxi cabs don't stop. And they don't line up at the pubs. They line up at the doner kebab stands, which stay open till 2 a.m. So everybody stumbles out. They get a doner kebab. Think kind of like a gyro. You'll get a doner kebab, and then you go get in the cab and take the cab home. And then you eat as much of the doner kebab as you can before you pass out. And then you wake up in the morning and you eat the rest of the doner kebab. Because, yeah, it's still good when you're drunk. It doesn't matter. But I've never been hungover when I do that, where I eat something before I go to sleep. If I go to sleep with a stomach full of alcohol, I'm hungover like you wouldn't believe. Yeah, and then the next day you get up and start drinking a ton of water. Or if you're in the Army, you just give yourself an IV and make it to PT. Because the Army folks in their med kits that they carry when they deploy out, they always have at least one IV. And so yeah, they're always like giving each other. If you go into the barracks Monday morning at like 4 in the morning, it's almost like being in a hospital where they've got somebody that's gone around and popped everybody's IV in. It's funny, they're trying to hydrate before PT. Oh God, yeah, I've done Waffle House before. I've been kicked out of a Denny's because we fallen asleep in the booth at Denny's. But yeah, I can't do Waffle House anymore. I've tried. After my gastric bypass, I cannot do Waffle House. It is way too greasy. Exactly, Pez Liz. So it's basically like a pita or some type of bread like that with the shaved lamb with lettuce, tomatoes, onions, the donor sauce, or you can get garlic sauce or tzatziki sauce, basically. Yeah, and they kind of wrap it up, and yeah, it's awesome. German beer is pretty low alcohol by volume compared to Belgian beer, but compared to U.S. beer, no, it's higher. And not only that, but German beer is amazing. Like, if you're going to go over to Germany and drink a Pils, one, shame on you. Two, it'll still be better than a Pils you'll get here in the States. Like, it's way above like Bud Light, Coors. Yeah, like you'll come back from Germany drinking a German Pilsner, and like you'll be a beer snob to everybody that's drinking beer here. But the thing I like in Germany is you've got Maibach, which is only brewed in like May, early April. I'm sorry, late April, early May. You've got Doppelbock, which is another one that's brewed at a specific time of year, but you can sometimes get it otherwise. Here's the thing with like Maibach and Doppelbock and some of the other beers that they brew in Germany, they're highly regulated, and you can only brew them during certain times of year, which means they're basically limited run. When they're done, they're done. When your local brew house sells out, you're traveling trying to find a brew house that has more, right? And they normally take orders. Like the Castell Brauhaus out in Mainz-Castell near Wiesbaden, Germany. It's between Wiesbaden and Mainz, the city of Mainz. I would literally go in and pre-order cases of beer. Yeah, there's beer purity laws and everything like that. So they will come out and test and make sure that you follow the recipe, that it meets the right alcohol by volume content, and that you stopped brewing at the specific time. You can continue to sell as long as you have stock, but you can only brew for a certain period of time. And then Dunkelweizen, right, is a wheat-based beer, and it is amazing. It's a little bit of an acquired taste, but it's amazing. And you would drink an ein groß Bierbitter, like an ein groß Dunkel, right? So one large Dunkel, which is normally like, well, it'd be probably about a pint normally, but if you do that during Oktoberfest time frame, you're getting a liter, right? And you drink one of those and you will feel like you have eaten an entire meatloaf by yourself. I mean, it's amazing. But yeah, you definitely don't, you don't go start drinking beer in Germany on an empty stomach. That's a bad day. And then going up to Belgium, the Belgium beers, like I've seen a Belgium beer that's over 20% alcohol by volume. And it's going to be very sweet and it's going to have a fruity aftertaste. The one that I really liked was the Dragon Brune. And if they didn't have the Brune, which was a dark beer, then I would go with the Dragon Blonde, which would be the lighter beer. But those were both like 14, 15, 16% alcohol by volume. And I would get that. There was a place there that I never knew the actual name. We just referred to it as Steak on a Rock. And you would go in and order the cut and size of steak and what sides. And you would get like this hunk of steak and your side on like a lava stone that was just sizzling. And you would just slice that steak thin and cook it yourself right there, and cook it and eat it right there, and drink a good beer with that. Fabulous. And then I went to England, first time in England, and it was near my birthday, so they took me out on my last day there, and they took me to some local pub, and I mean this pub was out in the fields, right? And lamb chops, and so this was a plate of mashed potatoes, and it had 3 lamb chops on it, and they took caramelized onions and just draped it over the top. And then I had a pint of Guinness with it. Best meal ever. Like, it was grand. So yeah, good times. They got me start. Yeah, I started talking about, because we don't have the tool head wiring done, that we had to hold our wires out of the way, like we were holding, a lady's hair on the day after a night of binge drinking. So we had to hold her hair up, and they started being like, "Oh, Luke, ever the gentleman." So I, started off on some drinking stories and time in Germany. Yep, Brit Love, thanks. So we have successfully got so where we left off, Chris, we were trying to get our Raspberry Pi Zero working, and apparently, as you can see, we don't have a Raspberry Pi Zero on there, because both of my Raspberry Pi Zeros that I found were actually the version 1.3 of the boards, which didn't have Wi-Fi. Which makes sense, because both of these boards, where were they? Both of these had a Red Bear I/O hat on them, which, funny enough, I'm not sure. I don't think it adds Wi-Fi. I think this is like a long range. It might add Wi-Fi. I might have to check that out. I'll have to look this board up. But I thought this was more of like, I was trying to use it as a point-to-point to extend LAN connectivity out to another part in the house. But this might actually be a Wi-Fi hat, and if it is, then I'll throw this on here and just add to the stack that way. We'll give that a try off stream. For now, we've got a Raspberry Pi 3B sitting over the SKR Pico board. Yep, oopsies. And the nice thing about that is I've now got a printer config file, and I'll say I cheated, right? And when I say I cheated, what does that mean? Well, I came in here into the browser, right? So this is, it says Baby Belt Mac 3D. It's not. This was a one that I was using on the NAC 3D build. But I came over to Gold Dragon, which is this printer here. This printer is running a BTT SKR Pico board and a Raspberry Pi Zero. So I basically copy and pasted this entire printer.config file over to the Rook 2020 printer and just changed a couple of things. So we came up here and said, okay, it's Rollon Rook 2020. It's got the Rook CHC hot end, a direct drive orbiter V2 with filament sensor. Blah, 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 blah. Everything else is the same. We went and we grabbed some extruder settings off of Death Dragon, which is the 0G that's standing behind me, the one that was sitting at your table, because it's running an orbiter as well. So all of the configs for that should be here. I'm going to lift the same configs for the filament sensor for the macros from that as well. And I don't think those were in the main file here, though I'll double check. Yep, not in there. So the other macros would be over here. Yep, orbiter sensor config. So all I'm going to do is I'm going to download a couple of these files to the local machine. So I'm going to download the orbiter sensor config. I'm also going to download line purge and adapt. No, we don't want to do adaptive mesh. We'll go ahead and download that and upload it just in case. And I say just in case because there is a possibility of putting a sensor on this board or on the tool head that I might do down the road. So we'll go ahead and we'll add those couple of things here. I don't need Klipper screen. Yeah, so all we're doing is I'll say, we're lifting a few things. We're going to grab the macro file from Gold Dragon. And then we'll just come over here and upload a couple of things. So there is a macro file here today, but it's probably not the right one. So actually, rather than upload it, we'll just do a Control-A, copy. Control-A, paste. And just like that, I've got the same macros between my rooks. So cut and paste is always good. Yeah, maybe I won't do the adaptive mesh and line purge just yet. We'll do that down the road maybe. I do need to upload the orbiter sensor config file though. So we will upload file. Oh, like why is it not downloading? Yeah, so Chrome blocks .cfg files by default. So, oh, exactly. I say cheating, but rather, like, I could do a video and go through and do a full line by line. There's plenty of those out there. What I do is I actually just take it and do a copy paste because it goes a lot faster. And the only difference between my 0G Mercury downstairs and my 0G Mercury that's upstairs right behind me is, well, one, the Manta boards, one's a 1.0 and one's a 1.1. The only thing that's really different is the size. The one downstairs is based on a Ender 5 Plus, which is 370 by 370 by 420. The one upstairs is an Ender 5 Pro size, which is what, 275 by 275 by like 250. So that's the only real difference. So over here, we're going to say upload. We're going to grab that orbiter sensor config. And we're going to make sure that we rename this to get rid of the one parentheses. And we're going to have to call that file as well. So I guess the easiest way is just to copy it. We'll come into our printer config, and we'll need to add that to our includes. So square bracket, include, orbiter sensor config, close square brackets. We'll do a save and restart. It may bark at me because we don't actually have the pins defined or the right pins defined, which I expected. So we will have to come into here, and there are a couple of pins that we'll need to define. Pin number 1 up here. So we're going to have two of the wires that we'll have to define. And what I want to use, so I believe I want to do the servos and the probe. Or I can use the servos and the E0. All I need from either the E0, so I need a 5 volt, a ground, and 2 open GPIO pins. So what I'll do is I'll either use E0 and do 5 volt ground and one of the IO pins, and then just use an IO pin on a different connector. You know, that's what I'll set up, is basically that way. I'm still on my first 20-ounce cup. I'm slow rolling it this morning. This is 2 K-cups though. I do need to make a note though. What I do with my notepad. There it is. And by make a note, I need to pretty much define what I'm going to plug into where. So, on the SKR Pico, I'm trying to think out loud because when we looked at the manual before, and we saw they had, okay, so there's our RGB light. Then it shows a BL touch. And that's what I was looking for, was this GPIO pin for the probe. So on my diagram, it just says probe. It doesn't have the GPIO pin. So that's what I need, is this is GPIO 22. So what I'm going to do is I'm going to use the like the BL touch stuff for the filament runout sensor, right? Because remember, I need the two GPIOs. One is there's a button here on the top that you can press, and that's your unload button that'll run the unload macro. The other one is on the board internal. It's the same, it's exact same momentary switch button. And what happens is when you put filament in here, it pushes a steel ball over that contacts that button. So I will use the ground 5 volt and GPIO 29 for the one function, and then I'll just do another, use another pin over here, GPIO 22, for the other function. And I'll figure out which one I'm going to use which. Because I'll have to make sure and get the right color of the wire to the right pin. So servos, IO 29 probe. Okay, and so what I can do now that I know what those two pins are going to be, let me bring up the orbiter information so I know which color pins are what. Over V2. Orbiter projects. Okay, so the green wire is the filament sensor. And we'll add that to the green will be on the servos. And then the probe will be used for the filament unload. So when we come in here, our G-code button sensor FS, this is the filament sensor. So this one, we will put in GPIO 29 And we need a GPIO. All right. And then for the FU, the filament unload, this one will be GPIO 22. And the GPIO is all lowercase here, by the way. Hey, welcome on in, Nick. We're just we're coming in here and doing a little bit of software config. I can't do any more wiring just yet until I get in some boards. So filament loads already registered. Okay. So that means I have 2 filament loads and I may have 2 filament unloads. So what we're going to do is, because we have separate macros in that orbiter config for this, I'm just going to comment these out. So with those 2 commented out, now when I do the save and restart, it shouldn't have any issue with the other 2. Boom. So we should be good now. So once we get these wired up, both of these should be working. And what I'm going to do real fast, nothing there. Let me see if I got a notification that the package has arrived. Still listed as out for delivery. I guess the mailman may be running a bit behind today because of the weather. So I guess what we'll do is we'll talk about one of the things that I was doing and how I plan on mounting some things. So because this is running an orbiter, by default, if I mount a regular standoff on here, the wires are going to be off to the side. So on an orbiter, you've got these pieces here that you can mount that will mount on the angle and then give you the 2 holes that you can use to mount your board, so your board's vertical. And then this top piece here will let me words sometimes will let me actually mount, strain relief. Words, I tell you. Hey, Zombie, how's it going? So yeah, so I've already got the heat set insert and stuff on here, and I've got my little standoffs in place. Come on, you. Okay, so this is mounted. We'll mount our EBB board on here. And that will give me my my strain relief for the 14-pin cable that'll come down into the EB, or not the EBB board, but the Pico umbilical board. And then for the other board, so that all of the tool head wires will come to this board, and then the wire for the filament runout sensor and the 14-pin wire, I'll join them right here. We'll loop them back up, and they'll come right down to a board that'll mount here. So what I did was I found a cover. So this cover is the same size as that printed circuit board. And the way it's designed for fitting onto a V0, you've got a cutout here that your Z in-stop wire would be able to come down through. And then it's made for a screw to come up from the bottom and hold the board to the bottom of the motor mounts on each side. Okay, so that obviously won't work for me. So I have to figure out somehow to leverage these holes and mount them. So my first thought was, well, we've got these pieces right here that are made for holding the vent grill on a Voron 2.4 or a Trident. So it's an M5, and then there's an M3 screw that goes through here, and it goes through like 3 pieces, right? So my thought was, well, does that line up? And can I use these? And the answer is, well, yes, I can. So that would be able to mount just like that. I'm like, okay, tad bit off, but it'll work. So then what did I decide to do? Well, because these are half holes and half holes, there's no real way for that to work. So basically, I pulled this into Prusa Slicer, pulled this into Prusa Slicer, combined the 2 files together, and then said, well, that looks a little funky at the end. So I took another one of these, cut the ends off. Long story short, here's my mount plate. All one piece. This is a little bit thicker than this plate, so I dropped it down so it's all the same thickness. And this is basically a protective plate. So my board will come up underneath here, and I will screw through the top with a nut at the bottom to secure the Pico umbilical board in. This will mount at the top with 2 M5 nuts. My 14 wire connector will stick through the top here. We'll plug that in, and we'll be able to bring our filament sensor wire right down through this spot here, put a zip tie through it to hold it in place, and then we'll run all of our connections down to our Pico board. And bada bing, bada boom, that's how we're connected. So that's really a way that you can take, rather than come up with a brand new design, I took an existing design and did some modifications and some jumbling to where now we'll have a nice clean back plate that we can do a Pico umbilical here for our build. So what we can possibly work on is our cable for our filament sensor. So the nice thing is, one, this cable is pretty much like you would get a motor cable. 4 wires twisted together, kind of like you would with a motor panel. The funky connector here, which Chris, you had you would see these. These look like the connectors that would go on your Duet Wi-Fi board that you're using, or your Duet board that you're using, right? This is the connector that goes into our filament sensor. So just line that up and push that onto the filament sensor. And then once again, we're going to bring this around and it will join up with the other one. It'll go with our board. We'll bring it in, bring it down to here. So we can probably cut this off some. What I'm probably going to do is just leave it at the same length so I can use it somewhere else later if need be. And nah, I'll probably cut it. We'll make it a little long, but we'll... And the reason I'm saying I'll probably cut it, because it's got DuPont connectors, and we don't want to use DuPont connectors. We'll want to re-terminate it for the JST connectors. So we're going to have to cut the ends off and re-terminate it anyhow. So we might as well make it, you know, a little bit easier to route. This is not going to be this tall anyhow. So that should give us plenty of room to route it and then some. So I'm going to cut this a little shorter, and we'll go ahead and terminate this end in the wire setup that we're going to use. Means now I'm going to need to get my wire strippers and crimping tools. And did I see Timor sneak in here? Because if so, I have talked with Scott. He's supposed to get back to me today. And that's the thunder outside, so the storm is here. So hopefully we don't have an issue where we lose connectivity or power. If we do, I apologize. But yeah, crimping ain't easy, but we will do a little bit of crimping here. That's not too bad. Okay. So not sure, like I said, I didn't know if Timor was here because I believe he's the one that's been asking about. Yeah, he is. So the Core XY, the Ender 3 Core XY build. I talked with Scott yesterday and asked him if that kit comes with the ByQ H2V2S extruder and the SKR Mini options, or if I needed to source those myself. He said he would look. He said he's never opened the box. So the plan is I reached out to him and said, hey, you know, I know things are pretty busy. You're just recently getting back and everything. You're going to IRF. I'm going to IRF. Don't worry about mailing it. If you can, bring it with you and I'll just get it from you at the show. So that's definitely not going to get here until the end of the month when I go to the show. So first thing we're going to do is just strip off the ends of some wires here and get our crimps on. And then we'll work on getting them in the right order and in a couple of connectors. So we'll strip the ends off. And Chris, I would definitely like to work on that beta build that you're working on. So I need to talk about that between now and at the show or at the show. Because I would definitely stream that however you'd like me to. Okay, so we're going to go ahead and get our items crimped on here. Yes, the new pressure slicer is out. I didn't download it before I did my little shenanigans to that file, but it's definitely out and available now. So where the last time when we were doing our crimps, the wires were fairly stiff. These wires are fairly stiff, but they're fairly small as well. So what I tend to do is hold the pin, because I find if I don't, and this one just did it on me. I don't know if I can get it close enough to show you. What happens is, I'm not sure if you can tell, but this leg here, rather than crimp down and over, it kind of folded down. So I have been known to actually just snip the legs down a little bit on the smaller, thinner wires so I can still get a good crimp on them. Because if you don't do anything with that leg, it will impede the pin going into the connector. So just something to be aware of. With the smaller wires. I know Chris knows that on his Lenio FEP wiring harness. Well, hi, Ryden. Is it Ryden or Raiden? Ryden. Hello. Welcome on in. Thank you for being here and hanging out with your dad on a Saturday morning. Two down. Well, the good news is that I don't have to go out and mow the lawn today. The bad news is it's going to be like 5 inches thick when I do go out and mow the lawn. Okay. And one more. But for those of you that aren't aware, and I'm sorry, I don't have a mod and I don't have anybody that can do shout outs right now. But yes, we've got a lot of content creators in here, like KB3D, who was streaming last night, Creatix Brit, who was also streaming, I believe, last night, Pez Liz, Zombie Hedgehog, Photosmit's been known to do a stream or two here and there. Don't know why this one's being a pain in the butt. It keeps trying to angle on me. Okay. So we'll need to know our wiring scheme again. So let's come back over and look at our orbiter color code here. And then I have, for my connectors, I'm going to have a 3-pin and a 2-pin. So I will need a 2-pin and a 3-pin JSTXH connector. And on my 3-pin, it's going to connect in that orientation with the little clips towards towards my left. So the first pin is going to be ground, and ground is blue. So we'll put the blue pin in. Next will be the 5-volt power. And the 5-volt power is the red wire. And then next is going to be, we decided, was the filament sensor, right? Which would be the green wire. I seriously hope you guys heard that. That was seriously crazy. Hey, MTB Matt J, welcome on in, welcome on in. So we're going to do the green wire next. If I can get it to twist in the right direction to line up in the socket. Okay. And then on my 2-pin, same orientation from left to right would normally be ground, and then the probe, which is the IO22. That's going to be my filament unload sensor, which is the yellow. So I want that on the right-hand side of that connector. Just like that. So this is now going to be the 2 connectors that I plug in for my filament runout sensor that we will mount once we get our boards mounted, that we can connect in now, but will actually get mounted or included in the board. We can run it now. It's behind the motor wires. Thermistor.